So we're going to have a look at the vacuum chamber test, vacuum box testing or bell. So some of you might be more familiar with the old traditional type of chamber with the separate pump or vacuum pump on it. So working as two components which link together. So here we've got the vacuum pump, and the hose line here connects in with all the pressure gauges shown on there. So that's kind of still available, still functioning. A lot of people use it, and you can see the size of the dome. It's quite a nice, manageable size. As opposed, well, they've got the new version now, which has got the pump, the vacuum plate, which is built into it. So the pump, we've only got one component that's needed on here. And as you can see, we've got a glass panel that we can view any non-conformances that go on. So again, but a little bit bigger in size. So if you're in kind of tight, confined spaces, it might be a little bit more problematic. But let's have a look. We've got some samples that we've been working on today. So let's just run up a pump on it and see what happens. Okay, well, we said we're going to have a look at the vacuum plate. So what we've done, we've got an example of membrane, and there could be kind of suspect areas, might be dents or indentations. Confirming it, yes or no, who agrees with what. So this is where the plate comes into play, and we're going to be using a bit of soapy water here. So we're just going to kind of locate the suspect area. Yeah. Put that on there. Going to bring the plate in. Now this gets pretty noisy in a moment. So when I fire the pump up, basically the gauge will inform us of how much vacuum pressure there is in the chamber. But we're going to be looking for any bubbles or obvious signs where air might be coming in. So I'm going to just put a bit of weight down. So if you bring the camera a little bit closer, I'm going to fire it up, so excuse the noise, and let's see what we find out. So there, we clearly had some bubbling occurring. So let's just run that again, just to double check on that. Partly me taking my hand off didn't help there, but we could see the pressure gauge was holding, but there's a non-conformance in there. So we need to be mindful of getting that patched and repaired, marked up accordingly. One good thing, it cleans the membrane, which is very rarely done by a lot of guys. But also be mindful, if you are doing any vacuum tests on those capillaries again, we talked about them earlier on, try to put the vacuum box on there with that capillary at that point. It's going to let air blow through. Let's just see what happens here if I fire it up again. We could see, look on the inside of the box, you can see all the bubbles that have occurred. That's where it's drawing air into the vacuum. So next up, we're going to look at the tensometer. Again, ASTMs exist for this, so refer to them for the specific requirements. But before we start the test, we need to cut the coupon that's a required size. So we're just going to take one of the air pressure seam tests. You can see this is where the needle went in, but we're going to do some tensiometer tests on that now. So if I just get the coupon cutter out, so let's get that lifted up, put it into position. Got our coupon, all good to go. So let's just drop this into the machine and take it from there. So inserting the coupon into the jaws of the machine, we get the right settings there. So we can just see that clamp on. But also with the digital readout, this will give the parameters of how much tensile strength. So this is measured in newtons. There is a variation. You can do this in pounds per square inch as well. A lot of the ASTM references pounds per square inch. But here we tend to use the Newton force. And we can see the jaws pulling apart there, pulling on the membrane. And if you can see the distortion that's occurring, just pointing it out there, showing that the membrane is actually weakening as opposed to the world. So slowly but surely, eventually that will top out and give a final reading where it meets its peak performance. Test now, which is a peel test. So last time we were doing shears, this time we're going to do it in a peel. So again, I've clamped up the membrane in the required formation, slightly different this time. So let's get the machine up and running. It resets itself on a new test, but let's look closely at what happens here. And those that have been on training with me always find this test is a lot easier. It always tends to pull apart. You can get more force manually doing this, but let's compare those figures that we saw first time round with the figures that are coming about this time. So slowly, we're at 155 at the moment. So it's peaked there. So the results were a lot lower in that formation. Again, requirements of what you expect the test to achieve. You will use the product data to see what its own tensile strengths are that it's gone through testing at against what you're achieving with the world in this instance. So you can record those results, and you would be possibly recording a percentage of these during the course of a visit, or if you want to do 100% on every weld, obviously you'd take a coupon in a strategically safe location. And remember, somebody's got to go and repair and patch up all these, but this is destructive testing with the live seam, but certainly valuable to do on your test seams. We used to do it on landfill all the time. We used to have one in the van, make sure we're welding properly.